And from this point on, I am going to talk a little about the sampling procedures. Now that you have learned everything related to basic probability theory. So this is basically, this slide, my friends, is the end of our journey. Okay, this is the end of our journey. Actually, I am going to upload a few videos more for the people who are interested in watching. And these videos are going to prepare you for the statistics course. Okay, either you watch these videos right now or you can watch them later. I am going to upload these videos in any way for you to watch. However, at this point, this is the end of our journey about the probability theory and the random variables. Okay. Now I am going to explain a few more things in the following 2 or 3 slides. Then the rest of this lecture, the rest of this slides presentation file, and there will be also another chapter, which is chapter 10. It is also a bonus chapter. These chapters and these rest of this slide is going to prepare you for the statistical studies. Okay. And I totally recommend you to learn about them, watch these videos, because it is going to be a good preparation for you for the statistical studies class. So let me give you the beginning, then I am going to leave you free. So we are going to talk about the random sampling procedure. So as I have told you, if you select just 1,000 randomly selected people from Istanbul and take the income level average of these 1,000 people, then that value will be a nice prediction to the true income level average of the whole Istanbul residents. Okay. Now, in statistics, we are always doing this. Our objective in statistical studies or inferential statistical studies, we always look at a small random subset of a great parent population, and by running statistical analysis on this subset, we want to make comments about the whole parent population. Okay, and that is the objective of statistics. Now, what is a parent population? A parent population is a collection of people or items or events about which you want to make inferences. So if you want to make an inference about the income levels of all 20 million Istanbul residents, that is going to be your parent population. If you want to learn about the GPA values, the distribution of the GPA values of all Özyeğin University students, then Özyeğin University students are going to be your parent population. Okay, this is the population for which we want to make inferences. Okay, inference means in Turkish çıkarım. Çıkarım. Ben ana kütle hakkında çıkarım yapmaya çalışıyorum arkadaşlar. Because the populations are countably or uncountably large, it is either too expensive or impossible to examine every member of an entire population. Ne diyor arkadaşlar? Genellikle bu ana kütleler oldukça büyüktür. Dolayısıyla bu ana kütledeki bütün bireylerin her biri için bir hesaplama yapmak ya da onları incelemek, test yapmak mümkün olmaz. Dolayısıyla ana kütlenin içerisindeki çok küçük bir kısma sadece bu testleri yapabiliriz. And that small portion of the parent population is called the sample, which is a finite subset of the population with manageable size. The term sample here may also refer to the observed qualitative or quantitative values regarding to the sample. So when we say sample, we do not just consider the subset itself, we are also considering the quantitative values regarding to that sample. For example, if you just randomly select 100 students from Özyeğin University and ask them their GPA values and write these GPA values in a list, that list is also going to be your sample. So by looking at these 100 GPA values, your objective is to make inferences about the whole parent population, which is the whole Özyeğin University students. And a random sample is what? Sometimes it is called a simple random sample. It is a sample in which each member of the subset has an equal probability of being chosen. Okay, so this is called a random sample, which means everybody is likely to be selected. Okay, nobody has a higher probability to be selected than the other one. So this is called a random sample. So let's just say my parent population is the students of Özyeğin University, and the simple random sample that I have is the body weights of n randomly selected students. And these n randomly selected students are actually random variables because we have not selected yet. Okay, we have not selected yet. We do not know which students we are going to select. In fact, if I ask you to randomly select 100 students, you are going to select a different 100 student than anybody else, right? So my 100 students and your 100 students are going to be different. Therefore, when you randomly resample or someone else performs the random sampling, it is very unlikely to get the same sample. Therefore, this sample is random sample, and each of the observations in this random sample are random variables. Okay? So therefore, if we want to study this sample, first we need to understand the theoretical properties of this sample, assuming that each of these values are random variables. Because you are randomly selecting the students, these random variables are also independent. Why independent? Because you are not sampling this sample like this. You are not asking one student and also asking that student to bring their friends. You are randomly selecting these students without looking at the previous selections. For example, when you select the first student, and if the first student has a low body weight, if you do not intentionally select another student whose body weight is high, then this is going to be a random sampling procedure. So when you intend to select the second person, you should not be influenced by the first selection. So every selection in this random sample must be independent of all previous selections. Okay? So in other words, the selection of a student does not change the ultimate probability of selecting any other student in independent selection. And these random variables are also identical, not just independent, they are also identical because they are coming from the same parent population. They basically preserve the probabilistic properties of the parent population, which means all of these random variables are in the same distribution. They are distributed with the same distribution. Therefore, these random variables are independent and identical. Now that we know these random variables are independent and identical, what do you think if you take the average? The average is going to be normally distributed, right, my friends? Because we have learned the central limit theorem. This means if you want to make an inference about the parent population by taking the average of a random sample, we know that that average of that random sample is going to be normally distributed. So this is told us by the central limit theorem. And this is why central limit theorem is one of the most important theorems in the world, because, I mean, every statistical procedure is basically based on this theorem. Now, as I have said, a simple random sample consists of a sequence of independent and identically distributed random variables, which is drawn from a larger population. And in order to make inference about the parent population, this random sample can be analyzed based on our knowledge about the probability theory. And suppose we want to learn about the average weight of all students. My question is this: what can we do if we only know about the weights of the students in our random sample? So I am interested in a knowledge about the average weight of all Özyeğin University students, all of them. But what I know as an information is just the weight of 100 students only. So what can I do with that?